Is the formulas for projectiles starting off. Okay, so before we do anything, you usually have it's still frozen ground. Thank you. You usually have two scenarios, right? Scenario A being you're throwing a projectile up a hill. Scenario B being you're throwing the projectile down a hill. So what we have to do is we're going to figure out both sets of equations, the generic equations that we use. Okay. So first thing is I'm just going to call these. I'm going to call the angle of the plane being angle beta, and then the thrown angle, which you throw relative to the plane, we'll call it A. Then it comes up and then drops down somewhere up here. Okay. Then we're going to do the reverse situation of that is where we throw. It's leaving at an angle A this way, and then it's on its way down like that. So one's going up a hill, one's going down a hill. At the very top, you use your basis of what everything you're doing here is phi equals u plus at, and s equals ut plus a half at squared. You're going to find the following equations: phi x, phi y. You're also going to find sx and sy. That's your list for each one. Okay. Now, first thing we're going to do is I'm going to construct a triangle going straight down. I call this my gravity triangle. I'll just get another colour for it. Use red. Okay, so you go straight down. You can make it as big or as small as you want. Now, the main thing is I now draw a line that's perpendicular to the hypotenuse. And then I draw another line that's parallel to it. So what I'm doing is I'm resolving these components. So what we have here is G. Now, before I did that, if you were to zone in on this triangle here, see this triangle on there? Yeah. That has to be 90 degrees. Therefore, that's 90 minus beta. This here has to be 90 degrees. Makes that beta. Okay? You probably remember that anyway. But there you go. Now you have your beta is in here. And what we're going to do next is we're going to break up gravity into its components. It's going to be g cos b for the adjacent side, and g sin b for the opposite. Now, just going to do the same thing over the other side. Once again, it's just the same triangle over this side. It's just that's pointing in the opposite direction, straight down. One that's going perpendicular, one that's going parallel to the hypotenuse. Same deal again. So I think it is. Yeah, it is. Yeah. That's beta there, and that's g cos b going this direction, and then you have g sin b going that direction there. Now, let's start off with v. Let's start off with Vx for the left hand side and Vx for the right hand side. Okay, 1 second. Okay, what about Vx for the left hand side? What do you think? Anybody? Vx u plus at? Oh, haven't done u yet. So I look at this here, and what I'm doing is going to break up that into its components parallel and perpendicular to the plane. I call the generic speed u. It's launched at an angle a relative to the plane, so it means that it's it's ux, if you will, its component parallel to the line of the plane. It's going to be u cos a. The other one is u sin a, and this is the same thing here. This part here, we're going to say is basically u going this direction here. And then we're going to have u cos a, u sin a. Everybody alright with that? Now, you go down to your generic formulas. What about the first formula? U plus at. So it's going to be u cos a. And is its speed changing along this axis here? Is there anything slowing it down? No. Huh? If you're traveling, what we're talking about, phi x is this direction here, or this speed here. There is what's slowing it down? Anybody? G sine B. Why is G sine B slowing it down? It's the part of the gravity that's in exactly the same direction, but going in the opposite direction. So remember, it's U plus AT, and U plus AT will mean it's going, and you're taking away, so it's minus GT sine B. Now phi y is the component that's going upwards. Is there any part of the acceleration that's going directly downwards? G cos B going directly downwards. Okay, so therefore what we're looking at is U sine A minus GT cos B. Now, what's the difference between going down a hill and up a hill? Now, first of all, phi y remains unchanged. You got it? Because phi y is still, the acceleration is still dragging it down towards the plane. Okay? So phi y has to change sign and hit the ground. Okay, that has to happen. So phi y stays exactly the same. However, there is a change on phi x. What's the change on phi x? Its acceleration of g sine b is in the same direction as your initial velocity u. So therefore it's going to be u cos alpha plus gt sine b. Now, once you have the first two done, what's the shortcut for the second two? Anybody remember? Add a t to the u cos part, so ut cos a, and then what do you do the second part? Gt squared, a half gt squared sine b, and then your next one then is going to be ut sine a minus a half gt squared, what's it going to be? Cos b, and this sy is exactly the same, ut sine a minus a half gt squared cos b, and sx, anybody? Ut cos alpha plus a half gt squared sine b. So once you've established that you're able to do one of these, you have both scenarios, and you should pick up a lot of marks just by even getting those formulas down and just trying to use them. You'll pick up the majority of the marks. So what we're going to do next is we're actually have a look at what question we're doing. I know where we've been looking, that has to be scenario A or scenario B. It's got to be one of them. So we'll figure out which one it is. So a ball falls vertically under gravity onto a smooth plane which is inclined at an angle tan inverse forward 3. So let's make our inclined angle like so. And then there's our inclined angle. And then the ball, which will be coming down from a height, hits the ground and then bounces off at some angle that I don't really know. Alright? So, what type of scenario are we looking at? Scenario A or scenario B? We're looking at scenario B. So the first thing you're going to do is, we've already made all these equations, so we're just going to group them together here. Then reduce it, and then we're just going to keep this up the top right hand side, and we can just pick from these equations when the time comes. So to use these equations, what do you need? To use these equations, we need a u value, we need a angle value, and we need the angle of the wedge. So we have the angle of the wedge. Okay, so that's a good thing. So we can start off just picking up easy marks, right? So it's at let's call B. Okay, B equals tan inverse 4 over 3. Tan B is then 4 over 3. You're going to use your 3, 4, 5 triangle. Opposite is 4, adjacent is 3, hypotenuse therefore is 5. We're going to get cos B is 3 over 5, and sine B is 4 over 5. Happy enough with that? Now, next thing we gotta do, a ball falls fairly under gravity onto a smooth plane which is inclined at an angle. The speed of the ball after impact. Alright, so, yeah.
How did you know it was done like that? It wasn't like that way, the wedge.
How did I know I wasn't dropping this way?
No, yeah, the wedge, how did you know it wasn't going to the right as opposed to the left? The vertical going up.
Oh, it has to go to the right because of the way it's angled. It's like any object that you fire straight down, unless it's going. Oh, you're saying wouldn't it draw like that?
Yeah.
It's a mirror image, so it's actually the same question.
Okay.
Yeah, it's a good point. I always take it going left to right because I could do it right to left, but it's just same thing. Now, guys, speed of ball after impact is 20. Okay. Which is inclined angle, the speed of ball, its coefficient substitution. Find the length of the first hop. The landing angle after the first hop. So this is quite a simple question. There's actually no rebound in it. It's actually telling us that the initial speed is 20. And coefficient restitution is 2/3. 1 second. Now, so what we have here next, guys, is the speed before your collision is 20. So it says the speed of the ball at impact, that's just before impact, is 20. So it comes down to 20. It's going to lose 2/3 of its speed. So with 2/3 of 20, it's going to give us what's it, 40/3, isn't it? 2/3 of 20 being 40/3. So the U value after your collision has taken place is 40/3. Now what we haven't determined is the angle. Anybody have any ideas how you're going to find that angle? See the way that angle's B? Yeah. So I'm just going to do is just going to shift this line further down. I just need a bigger triangle actually. I'll show you now. Just need a bigger triangle to make this work. Triangle's too small. Okay. So what happens is it's dropping straight down, right? It goes there. I'm going to draw it like it's going straight through. Okay. Now I'm then going to move this just down this way here. It's sort of like the gravity triangle. So that's going perpendicular. Perpendicular is there. There. Okay. Now this is the ball dropping this direction here. Okay. What angle does this have to be? If that's angle B, what angle does that have to be there? Same thing as the gravity triangle we did earlier. That's also got to be B. Okay. So once that's B, we're then going to find out. We're going to find out the speed it comes in before impact. Okay. So the speed it's going to be coming in before impact. Okay. So we know that these are the. We know that it's dropping at 20. So we're going to find the speed it hits the ground at perpendicular to the plane, and the speed it's going parallel to the plane. So in a way, I'm just sort of using a mini triangle here, like this. Like so. Okay. So, anybody, this is going to be 20 cos B is going to be your speed that's perpendicular to the plane coming in. And then 20 sine B is going to be your speed that's coming out parallel to the plane. Is that right? So, just do that separately now. We're just going to say that it's coming in here, going out this way, it's going across, it's at angle B. This is, sorry, 1 second. Give that straight down. Okay, and across. So, this is your angle B. This is your 20. Now, what is 20 cos B, lads? 20 cos B? 15. 20 sine B? Sorry, 20 cos B was 12. And 20 sine B? 15. Okay? So before your collision takes place, you're currently going. We call it what's it, minus 12i? Oh, sorry, 15i minus 12j. So everybody happy with that? 15i. Oh, 16 is it? Oh, sorry. 16i minus 12j. Okay. So you're on 16i minus 12j. That's using sine B and cos B respectively. So you're going 12 in, 16 across. Okay. Now, which component is affected by the collision? So when you're bouncing on your way out, which component is affected by the collision? The J component is the component that's affected by the collision, because the J component is the one that's going to lose the speed. Okay. So after collision, you automatically know that you're still going 16i. Has to happen that way, right? 16i still has to happen, right? Now, what are we going to be? We have to figure out what is the J component after collision. So how do we figure out the J component? Remember, it's basically coming down at 12, and how far is it going in the opposite direction after collision? It's going minus 12 downwards. You multiply by 2/3, isn't it? What's 2/3 of 12? So it's 8 on the way back up. So it's going 16i plus 8j on the way back up. Okay? So, what it then asks me to do is, it goes, find the length of the first hop. Okay, so the length of the first hop. Now, length of the first hop would be something like this. You're just after hitting the ground, and you want to go from here all the way to here. Okay, and we also have to find out the angle. Now, usually we'd say you have to find out the angle you get launched off at, don't you? Alright, now, the reason we do that is, let me explain what each component means here. What does u cos alpha and u sin alpha actually mean? If you know u and you know alpha, what is u cos alpha? It's the I component of your speed, isn't it? We already know u cos alpha. U cos alpha is basically 16. U sin alpha is 8. See, in the previous questions before this, we're always given the angle and we're always given the speed, so we can work that way. In this case, it's just easier just to get the component in the first place and not worry about the angle. Okay? So anywhere we see u cos alpha, it's going to turn into 16. Anywhere we see u sin alpha, it's going to turn into 8. Alright. Now, the next thing we didn't do was we didn't work with the components of gravity, okay? So, the components of gravity, it's actually already here. So, our gravity component is what, guys? And we tell what the gravity component is. It's cos B and sin B, and we already know what cos B and sin B actually are. So we're actually ready to use this. Now, when you're talking about the length of the first hop, how do you find the length of the first hop? The length of the first hop does it refer to a horizontal or a vertical distance? Or does it refer to a distance parallel to the hypotenuse here, or perpendicular to the hypotenuse? Parallel. So when you go here, in effect, we're looking for this red distance here. Okay? That's known as the range usually, isn't it? So you're looking for s of x when s of y equals 0. What does sy equal 0 at? Can you tell me? Because it has, when it finishes its hop, it has no height above the plane, so sy has to be equal to 0. Okay? So what we're going to do next is we're going to alter these formulas. So we're just going to use sx and sy. Sx, we're going to change u cos alpha into 16. And then plus a half, what we're changing sin b into? Sine B is 4 over 5. So it's going to be a half gt squared 4 over 5. What's sy equal to? U sine alpha is 8t, and then it's going to be minus a half gt squared, and what is it's cos b, isn't it? And cos b we know is 3 over 5. Now we'll just fix up the fraction straight away. Half of 4 over 5 is 2 over 5, so we just rub that out, just change that into 2 over 5 straight away. And then what about the second part? A half 3 over 5 would be 3 over 10. Nothing we can really do about that regards to fifths, so 3 over 10. Now, there's our two formulas. Solve the first one equal to 0. So sy equals 0 is 8t minus 3 over 10 gt squared equals 0. 3 over 10 gt squared equals 8t. Cancel the t. Then it's going to be 80 over 3g equals t. Your time of flight is 80 over 3g. Once you do that, you now insert it into the sx formula to find the range. So sx is going to be 16 multiplied by 80 over 3g plus 2 over 5g times t squared, which is going to be 80 over 3g squared. This is going to need a bit of help here. What's 60 multiplied by 80? Sorry? 1280. Okay. Half 4 over 5. Oh yeah, same thing. Yeah, it's actually going to turn out we have it perfect. Could everybody just ignore the g and just would you get 6,400 over 9g? So just ignore the g. Just do 16 multiplied by 80 over 3, and then just do 2 fifths 80 over 3 squared, and tell me that comes to, hopefully it'll come to 6,400 divided by 9. That's what I'm hoping for. That's the first question done there. Your range is 6,400 over 9g. Okay. The next question you're going to be asked is about the landing angle. Does anybody remember how to do a landing angle? Or what is a landing angle? Landing angle is where we're going downhill at the moment, to be fair. So a landing angle is when you come up and then it's the angle at which you hit the plane, isn't it? So it's usually, we're so used to looking at it going uphill. I think it's part of the problem as well. So we're so used to looking at it going uphill. It's usually just before impact. Okay, you have a velocity v, you have vx, and you have vy. Now, what's the usual deal about vy just before impact? Vy has to go in which direction? Down, which means it's negative. So the landing angle A, we'll call it something else because we already have A in this question. We'll call it X, are we? L. Okay, you said T. It's already used. Alright, so tan L equals minus Vy over Vx at TOF, which means time of flight. Okay, so what we're looking to do here is we're going to find out Vy and Vx at the time of flight. Now, we already got the time of flight earlier, didn't we? The time of flight is, we got it in the last question, it was 80 over 3g. We're now going to put this into the Vx and Vy equation. Now, the Vx equation becomes u cos alpha. U cos alpha we all know is 16. plus g sine b. What's sine b, lads? Sine b is 4/5. 4/5 gt. Phi y is 8, and that's 8 minus cos b. Cos b is 3/5. 3/5 gt. Now, what we gotta do, we're gonna have here, guys, is phi y is 8 minus 3/2 gt. So, what we're gonna do next is we're going to insert the t value in, and then find the landing angle, okay? So we do this for me. Phi x equals 16 plus 4/5, 80, 4/5 g, 80/3 g. Just ignore the g's and write down 16 plus 4/5 multiplied by 80/3. So we're given the answer for that. While you're working on that, phi y is 8 minus 3/5 g all over 80/3. So which is the first one? 112/3? Perfect. The second one? I think it's going to be minus 8. So your landing angle, therefore, your L, I think we call it, is your phi y, which is currently going 8 downwards, and it's going 112/3 to the sides. So we're going to tan inverse 8 divided by 112/3. Anybody know what that is? I'm going for 12 degrees. Is that good? 12 degrees. Okay.